Hi everyone, welcome to PSPM. This is the video showing you the solution for the question set N. So let's look at the question 1, part A. Question 1, we have question A, we have evaluate this function. Let's see how we're going to solve this. Alright, to evaluate limit, normally we will start with the substitution first. Okay, so you may start with the substitution. Substitute the 4 inside. You have 2 minus square root of 4, that is 0 on top. Alright, and then down here, if you substitute 4 here in the denominator, you still will get a 0. So once you have a 0 over 0 cases, you either will go for factorization, or you might go to multiplication of the conjugate. So for this question, we got 0 over 0, right? Now, we either multiply by the conjugate or factorization. Look at the function. We don't have any quadratic polynomial or cubic polynomial. So we can see that we have a term of the square root here. So probably we will use the conjugate. Alright, multiply by the conjugate. So the conjugate of the 2 minus third x will be 2 plus square root of x. And then remember that down here we also need to multiply by the same thing, so that this is equivalent to 1. Okay, then after that we are going to expand the numerator only. Denominator, the 4 minus x and 2 plus square root of x, do not go and expand. You just use a bracket to separate them. Alright, and then down up here we can actually expand. 2 multiplied by 2, you got 4. And 2 multiplied by square root of x minus square root of x multiplied by 2. These two terms actually can be cancelled off. And then negative multiplied by positive, you get negative. Third of x multiplied by third of x, you get a x. Now we can see that numerator we have a 4 minus x. Denominator also we got the same thing. So we actually can cancel this off. And we left 1 on top. After you have cancelled off this 4 minus x, you actually can use substitution method. Substitute the 4 inside, you have 1 over 2 plus square root of 4. So 4, that will be 1 over 2 plus 2, that will be 1 over 4. Alright, so you can see that the 4 minus x here is actually something that makes you got the 0 over 0 just now. So once you have cancelled this off, you can back to the substitution method, substitute the 4 into the x, then you got the answer. For the question B, given that we have this, we have given the limit when x approaches to 1, f(x) is equals to 2, and limit of the gx when the x approaches to 1 is 64. Now we need to get this limit. The question asks for this limit, so I just copy down the question. Now, for this question, we need to use this property of the limit to answer the question. Firstly, I will just split them, this limit, x approaches to 1. I will split this into 2 terms first. Into 2 terms of the limit, the same limit, but the function is different. And then after that, this can be separated into limit x approaches to 1 f(x) multiplied by the limit x approaches to 1 square root of the gx plus, alright, for this term, the square we can bring out and this term become like this. Because there is a property saying that the power of n here, it can be converted into these everything square, and the limit we put it inside. This is one of the property. You can check out your notes. And for the first term, we can actually, for the limit when x approaches to 1 for the square root of gx, I can convert this into this form. Again, actually I'm using this property. Okay, this property is roughly same as I'm using for this one, because you can imagine that the gx is having the power of 1 over 2. Then I bring out the power of 1 over 2, and every limit, not include this square root, I put inside the square root. Alright, this is also one of the property. You can check out your notes. Okay, so everything is ready to substitute the value because given that the limit of the f(x) is equal to 2 and limit of the gx is equal to 64. Now I will put in the 2 inside as a limit of f(x), multiply by square root of, this is given as a 64. Just put in the 64. And this is given as a 2. And don't forget we have a 2 square. After that, just simplify it. We have the answer 14. Alright. Sorry, this should be 20. Yeah, 20. 8, 2, that will be 16 plus 4, 20. For the question 2, we have given this is a piecewise function where a and b are constants. Find the value of a and b if the limit of f(x) exists at x equals to 1 and x equals to b. So we say that this question says that the limit when x approaches to 1, okay, of f(x) and the limit of x approaches to b of f(x), they are exist. So what does this information show to us? Okay, if I say that the limit of f(x) when x approaches to 1 exists, what does it mean? This means that the one-sided limit, it must be equal. I mean the right-hand limit, it must be equals to the, so this is a right-hand limit, must be equals to the left-hand limit. Okay, so when I say this limit exists, means that its right-hand limit has to be equals to the left-hand limit. So we are using this information to solve the value of the b, a, and b. Okay, we are forming the equation and later on we are solving the a and b. So when I say that the limit of x approaches to 1 positive, you should put in the function which is correspond to the 1 positive. 1 positive meaning that a little bit greater than 1. So the function which is greater than 1 is the a, because the 1 positive is 4 in this interval. So you are taking this function as a, put in as your f(x), and this has to be equals to the limit when x approaches to 1 negative. So you need to find the function, subfunction, which is correspond to the 1 negative. And 1 negative, we can see that is 4 in this interval. So the function that we're going to consider is x plus 4. So just put in your x plus 4 inside. Then we have an equation. This is my equation. Alright, this is the equation that I can form from this information. Then now I'm going to form the equation which consists only the a and the equation involving the a. So how am I going to find this limit? When you have a function a is a constant, you have a constant function. We don't care what is the value of x over here. We just get back our a when you evaluate the limit. For this linear function, you can use substitution method. Substitute 1 inside the x, you have a 5. So very easily, we already got it. A equals to 5. So to get the b, we have to deal with this information. So what does the information give us? We can see that if this limit exists, meaning that its one-sided limit must be equal, meaning that when x approaches to b positive, it has to be equal to the limit when x approaches to b negative. Alright, again, we are using this concept to form an equation. So what is the function we should put in here when the x approaches to b positive? So b positive obviously is in this interval. So we are taking the function x plus 1 put into our limit expression. Alright, so for the b negative is 4 in this interval, okay, which is between the 1 and b. So the function again is I'll put in is the a. So a we have found this now, that is our 5, that is 5. Then how are I going to, okay, I just copy down once again. Okay, then after that, I'll use substitution. Just put in your b into the x, you have got your b plus 1. And just now I have mentioned that if you have a constant function, we don't care what is the value of the x over here. We just get back our constant when you want to evaluate the limit. So here we can get our b equals to 5 minus 1, that will be 4. So we already got the value of a and b just by using these two information. Alright, this limit when x approaches to 1 exists, and limit when x approaches to b exists. So from here we form two equations. One equation is solving the a and the other one equation is solved for the b. So let's proceed to the next question. That is the hence find the limit when x approaches to 8. So when x approaches to 8, I think it's a simple question because 8 is not the boundary value. Okay, when x approaches to 8, what is this limit? So we can see that when x approaches to 8, the b just now we got it as a 4, right? Okay, we got it 4. This is 4. This is 4. And the a is 5. When x approaches to 8, you ask yourself, the 8 is 4 in which interval? You can see that the 8 is 4 at the last interval, which is x greater or equals to 4. Then we are taking this function to represent our fx. That is my x plus 1. Just put in the fx that you have decided to. And now we just can put in by using the substitution method. Okay, plug in the value of 8 here. You have your 9. That's it. Now we move to the question 3, still in the section 1, section A. The region R is enclosed by the curve. This is a quadratic curve. Yes, it's not quadratic curve, it's a parabolic curve, which y is square. And now the region R is enclosed by this curve and the y-axis. Sketch and shade the region R. Yeah, if I would like to sketch this curve, I can see that the square is at the y, meaning that the curve is either open to the left or open to the right. It's a parabolic shape, but it's not open upwards or open downwards. Open upwards and open downward is a quadratic curve that we learned before, that is either open upwards or open downwards. Okay, that is the square is at the x. Okay, but now the square is at y, meaning that it's a still parabolic shape, but it's either open left or right. And you can see that now we have a negative sign over here. So if this is having a negative sign, then we know the shape has to be open to the left. Okay, if this is all positive, the sign is a positive here, you have the shape is open to the right. So here we have choose our shape, but we do not know the shape is passing through which point. We need to find is y-intercept. Alright, to find the y-intercept, we let our x equals to 0. Alright, then we solve for it. When your x equals to 0, you have your negative y squared plus 7 equals to 3. And solve it. You have your y squared equals minus 4 equals to 0. Then you have your y equals to positive negative 2. Meaning that your graph will pass through the negative 2 and the positive 2. Continue by finding the x-intercept. So to get the x-intercept, we let our y equals to 0. Then you have your x plus 3 equals to 7. Then the x equals to 7 minus 3, that will be 4. Meaning that your graph will be passes through the point of 4 over here. So what you have decided just now, the shape is correct because the shape has to be passes through the 2 and it has to go to the 4 and it has to turn back to the left and passing through the negative 2. Alright. So once you have done the graph, you have to set the region R. Where is the region R? So again, we go back to the question. The region R is enclosed by the curve. This is the curve and the y-axis. Alright, so the region R, I'm going to shade it here. And you got to label it as R to get the complete marks, yeah? Okay, so here I forgot to label my graph. That is my x plus 3 equals to negative y squared plus 7. Okay, this is the graph. So now you want to get the area. This is A, B, and C. Sorry, A, B, and C. For the question A, you need to sketch the graph. So find the area of the R for the question B. To get the area of the R, we are going to integrate. Integrate from the -2 to 2. And the function, we need to put in x in terms of y, because this is going to integrate with respect to y. So let us find the x in terms of y. The function is your x equals to -y squared. 7 minus 3, that will be 4. Okay, so you are going to put in this function, that is your x inside, which is -y squared plus 4. Put in your -y squared plus 4, and then we're going to integrate with respect to y. Integrate as usual, you get your -y cubed over 3 plus 4y. And then put in your upper limit and lower limit. Get prepared for 2 brackets, just like that. And put in the upper limit, you got -8 over 3 for the first term. Put in the 2 inside here, you got +8. And then for the second bracket, we're going to substitute the lower limit. Lower limit you put inside, you have -8, right? -8 multiplied by negative, you got a +8 over 3 and -8. Okay, this is your 8 over 3. Alright, then have your calculator to calculate the final answer. So final answer, you have a 10 and 2 over 3 units square. Now we move to the question C. If the region R is in part A is rotated about 2 pi radian about the y-axis, find the volume of the solid generated. So now this region is rotated about the y-axis for 360 degrees. So now we want to get the volume. So when this region is rotated about the y-axis for 360 degrees, we can actually foresee that the shape is like that. Okay. A little bit longer. Okay, the shape is like that, something, the solid. Okay, the solid is some sort like that. Okay, it's just now you want to get the volume of this solid. You're going to integrate with respect to y as well. Part C, to get the volume, don't forget the formula. You're going to start with the pi. And the same thing, we are going to integrate from -2 to 2. And now this, this function, we need to put in the x squared. And now we integrate with respect to y, because the volume, the pieces is actually rotate about the y-axis. So now get your x squared. What is your x squared? Since your x is equals to -y squared plus 4, means that your x squared will be -y squared plus 4 power of 2. So I just put in the x squared as a -y squared plus 4 power of 2. Now to integrate this, we need to actually expand first. Expand this, you have a y power of 4 minus 8y squared plus 16. So once you have expanded, you can actually integrate. Integrate y power of 4, you get y power of 5 over 5 minus 8y cubed over 3 plus 16y. And then get prepared to substitute the upper limit and the lower limit. Final answer, don't forget to multiply by pi. So I'll get prepared to big bracket to insert my substitution of the upper limit and the lower limit. So the upper limit, when you put in the 2 inside, you got a 32 over 5 minus 64 over 3 plus 32. Alright, when you put in the 2. After you put in the -2, once you put in -2, you're going to put in in this second bracket. So plug in the -2 inside here, you got a -32 over 5. Alright, and then you have your 8 positive 64 over 3 minus minus 32. And then calculate the final answer by your calculator. So you got the answer, 512 over 15 pi. This is what you're supposed to get. And the limit will be unit cube.